All right, y'all. So I want to walk you through this drug cost example. So what we're going to try and do is look at the cost of drugs or prescriptions based on a bunch of different covariates. The number of prescriptions per member, the generic substitution rate, a restrictive index of how restrictive the policies are, the copay on it, the age of the average member, the percentage of females on the prescription, and then the member months. So let's look at, and really what we're going to focus on is we're going to focus on these two variables, the generic substitution and the restrictive index. Now, I'm going to take you through two ways to analyze this data, and then we're going to look at kind of the steps too. So the steps on this are going to be, we're going to analyze it, we're going to make sure it meets assumptions, and then we're going to look at how you interpret. And then we're going to go through another way to think about this, right? So basically, we're going to say, okay, there's the way we do the work up front. There's the way we think about this. All right. So the first thing I'm going to do is I'm going to look at the summary of the data. So there's two ways to think about this. I'm either going to fit the model and then worry about meeting assumptions, or I'm just going to fit the model and then start thinking about, okay, what do I need to do? All right. So here's cost, here's prescription. Let's look at the distributions. This looks okay. This looks okay. When I say okay, I'm looking at the spread. I'm thinking about how everything goes. Minimum here 16, first quartile 37. That looks kind of okay. Might be something. Look at this restrictive index. See how that's zero point 0.3 up to 45? That might be something to worry about. Copay, age, that's okay. Look at these member months. 491 clear up to this huge number. Might have to take the log of that at some point. Let's keep an eye on. Now, first thing I'm going to do, the first way we're going to do this is we're just going to fit the model and we're going to see if it meets assumptions, see if we actually need to do anything here. So when we fit this, take a look. This plot looks fine there, but the thing that pops up is we have this influential point at Delaware. So we're going to come through here and we're going to say the Delaware is our big thing and it's number 19. So which one is 19? Delaware has cost of 131. So when I look at the summary of drug cost, 1.31 falls in the upper between the median and third quartile. 3.6 between the minimum and first quartile. Okay, that's weird. Generic substitution would be the minimum. Keep an eye on that. 7.7 between first quartile and the median. Copay, 6.07 between median and first quartile. Age, 52.1, or no, 29.2 between median and third quartile. Okay. Female, 52.1. That's going to be between first quartile and median. And member months is on the lower hat or the lower part, which isn't surprising because Delaware is a small state. So really what we're looking at, the thing that probably bothers me the most is this 16. So let's look at the cost between generic substitution because that's where we get influence. So I'm going to reset what the plot looks like, and we're just going to look at the plot with generic substitution. Now, see how spread out this is? See how far away this is? So when you normally we're used to seeing influential points on this side, right? What we have to do now is figure out how to make this thing big. So how do you take small numbers and make it big or numbers that need to be made larger? You square them, you cube them, you do those type of things. So the first thing I'm going to try and do is I'm going to try and cube something. Let's see if that makes it big enough. Well, it kind of pulled everything back. Let's see if that did it in a way that would make some sense. So what I'm going to do, remember, tilde period uses all the predictors. Subtract GS means take GS out by itself and then add back in the cube. That's what this is going to do. So I'm going to fit it and then I'm going to check the assumptions. All right. It fixed my influential point. Normality looks fine. This looks okay. We can always check by NCV test to see if it works. NCV test, it says we fail to reject the null hypothesis. Or yeah, or excuse me, we fail to reject the null hypothesis, which means the non-constant variance assumption's met. So we're good. If you go in and check box Cox, everything works out fine as well. Again, just to make sure it works for us, this means you're met. One shows up in here, which means you don't need to do a transformation for normality. So everything's good. Now, if we look at the summary, what this is telling us, you can go through and you can do all your interpretations. But really, the significant predictors in this are age, prescriptions per member months, and the generic substitution rate, which are Interesting for us because we said what we're really interested in are this restrictive index and generic substitution per month, or the generic substitution variable. So really what we want to do is say, are these two things significant? The most important thing for us is saying, is this restrictive index significant? So what I'm going to do is I'm just going to remove it from my model, make sure the generic substitution cube's in there, and I'm going to run an ANOVA just to remind myself, is this thing significant? Here's my ANOVA. The p-value is big. So I have nested models. I have model one and model two. I'm going to make the comparison. Remember, if I reject the null hypothesis is this a small model. Um, the null hypothesis is the small model is good. The alternative hypothesis is, yeah, I need the bigger model. So if I reject the null hypothesis, I'm choosing the big model. If I fail to reject the null hypothesis, I'm choosing the small model. In this case, the p-value is large. I fail to reject the null hypothesis, so I'm choosing the small model. In this case, the one that removes restrictive index. And so what we're saying is we don't need restrictive index in our model, which means it's not important to the analysis. Okay. So what it says is restrictive index isn't driving cost when we adjust for everything else in here. All right. So if we go to look at the summary of M3, what it's telling me is here are the things that are significant, right? All right. So I can look at things like, hey, this is what generic substitutions are driving down cost. So the more generic substitutions you have, the lower cost you have. That's an interesting idea, right? That's what we're able to say about the cost of prescription here. All right. So the higher the copay, the higher this number, or the higher the cost of prescription. Now, one of the things we could have done if you go back up here, and this was the second way I was going to tell you we're going to analyze, and again, we can look at effects plots, and we'll do that here in a second to finish off the analysis. But one of the things we talked about was if you were looking at this, one of the things you could have come back and said is, I don't like the ratios that this restrictive index of these member months are. So if you were doing your work early, like we kind of talk about when we're doing transformations, I could have taken a log of the restrictive index in the member months. Let's look at how that would have changed our analysis, or would it have done anything different? Would have changed how we think about restrictive index. So let's come in here and let's reset the analysis and let's fit a model with log of restrictive index and log of member months, and let's see if that would have changed anything. All right, so let's fit this M4, which takes the log of the restrictive index and the log of member months, and let's just look. Log of restrictive index, log of member months is now significant at the 0.06 level, or 0.1 level, I'll say. Log of restrictive index, the p-value changes, but it's still not significant. So let's drop restrictive index and don't put log of restrictive index back in, right? And let's test the difference between model 4 and model 5. Whoops. So all we're going to do is run an ANOVA to say, is restrictive index important, using log member months instead of member months? And basically what it comes back and says is no, it's not important. Restrictive index, even if you take the log, isn't important. Even if you try and control for this variability that's in there. Notice it changed the p-value, right? But it's not important, even with this transformation. So that's something good to think about. That's something good to note. So looking at the summary of M5, right, when we come in here and we look at this, you're seeing the effect now. You're seeing log member months is now significant. The generic substitution variable is significant. Age is significant, right? And RX per member months is. So if we want to do an effects plot, now notice female and copay still aren't significant, right? So if we come in here and we look at this, you can see copay and female. See how I could draw a straight flat line through the light blue? Because that's the confidence interval, right? I could draw a straight flat line. You couldn't really with this. It would cut it off someplace. It would cut it right here. But with copay, I could draw a straight flat line. Same way with female. Same ideas here. But look at what's significant. All right. So let's fit a model 6. Let's fit this last model. Let's see what happens if we drop copay and female. And let's run the ANOVA between M5 and M6. All right. M6 says this simple model. This ANOVA says we fail to reject the null hypothesis. The simple model wins, which means M6 is the model we'd like to select. It only has prescriptions per member, age, this generic substitution, and the log of member months. Now, if I come back and I look at this, here's what I come back with. I'm going to plot the summary right here. Take a look at it. It says I have this negative effect associated with age. So cost goes down as age increases. But look at the average age. It is the average age, right? The number of member months. Cost goes up as the number of member months goes up, right? But it's not this huge. It hits this critical mass and then it kind of asymptotes. Generic substitutions drive costs down. But we know that has this extreme effect of Delaware, but it still seems to be holding true up here, right? We know that's true. And we've adjusted for that so Delaware isn't highly influential because of this cubic effect that we put in here. We have this linear effect of RX per member that we see that increases across time. So the number of prescription per member cost increases as you go up, right? So number of prescriptions drive up the cost, right? So the more use it is, the higher the cost it is. So again, this is the way we can use effects plots, but this is also the way we can do this. Now, if you want to really bring this in to some other tools, and some other things we've talked about in module 5 with model selection, we could have just started from the beginning and just done like a step AIC. And that's one of the things I challenge you all to do now that you know it is what would you have come up with if you'd have done the transformation from the beginning and now run backwards selection? What would you have got? How would step have done this for you? Right? How would step of M1 done on this? Right? You'd have come back with copay, RxPM, age, and GS. What would step of M3 done on this? Right? It comes with RxPM, copay, age, GX3. See how it doesn't come back with those member months? Right? Now, if I come back and I put in M4 on this, notice the only thing it would drop, it drops log of RI and it drops female. It leaves in log member months. It leaves in log of RI, right? The only thing it drops is female. AIC would tell you stop there. So notice model selection tools will give you something different than ANOVA, right? It depends on what you're looking for. When we went through this process, when we went through the ANOVA process and used it step by step, it came back with a different tool. So notice when I came in with log member months and did something different on this M5, right? Excuse me. When I dropped copay there, right? It left copay. It left copay. So when I dropped copay and female at the same time, it did something. What happens if I'd have put copay back in right here? Do you think we see something different? What happens if I put copay right here? Copay isn't significant, right? Copay isn't significant in this model. But AIC is saying keep it. AIC is saying keep it. AIC is saying something is in that model that makes it useful. Remember, AIC is doing something different than what ANOVA is trying to do. AIC is creating this trade-off. So that is something to remember. Remember, when we do these stepwise selection, it is different than ANOVA. That is something to keep in mind. So when you're doing your model selection, when you're doing these type of trends, remember there are different goals. What are you trying to say? Are you trying to do statistical significance? Are you trying to balance the number of predictors with the fit? What are you trying to get at and how are you trying to approach it? These are all things you think about. Assumptions are really important for your inference, right? Are you trying to build prediction models? Are you trying to go to cross-validation? These are all tools and all things you think about. But there's your process. Your process is look at your data. Does it meet assumptions? Do you need transformations? Sometimes different transformations will give you different results. But this is where we can use effects plots for our interpretation, right? These are real easy cells. These are real easy discussion points. Okay. My process is always, I'm looking to do my transformations, make sure those base models meet assumptions, and then I start reducing my number of variables. Okay. And then I start pruning it. That way I can discuss it. Because at the end of the day, the idea is I need to be able to talk about my model. Does it predict well? Does it have nice discussion points? The idea that I can say generic substitution drives down the cost is really good. And then at some point, we hit this asymptote with the number of member months that it really doesn't affect cost anymore because you've hit that critical mass. The more usage you have in a plan actually drives up cost. That's an interesting idea as well. And then this age drives down cost is something that maybe somebody wants to look at. So again, how you have these interpretations and how you think about these things are really important as well. So, all right, that's the end of this example. I'm going to shoot one more video for you about just process and how we think about workflows and everything that goes with it. But let me know what you need. Let me know how I can help.